perspective for CNCF. So, first speaker is Veera Solayapan. He is going to speak about observability driven deployment development with OpenTelemetry. He is a senior software developer at Tech Systems. He having 4 years of experience in software development, various domains such as GIS, e-commerce, supply chain, etc. So, Veera, are you ready for that? Hi, Veera. Can you hear me?
Yeah, hi, sir. Hi.
Yeah, yeah. Yeah, stage is yours. Yeah,
Yeah, thanks, guys. I hope the session is also getting ready. Yeah, cool.
yeah.
Yeah, thanks, guys. Thanks for having me and giving the opportunity to present it here. So, let me share my screen. I hope my screen is getting visible, right?
Yeah, yes, yes. Yeah, I
Okay.
can see.
Okay, guys. So, as per the schedule, we are going to look into about observability driven development, how we can implement using OpenTelemetry. So, in specifically, we are going to look into about what is observability driven development and why it's really important, and then how observability driven development will help us for our day to day software development life cycle, and then how open telemetry and Jigger works internally. What are the tools it has? What are the components it has? And then how the architecture flow is working there, and then how to instrument our application using open telemetry. Instrument is nothing like but how we can get the data, like the data means observability related data. It's like traces, metrics, and logs. How we can get it from our application, that we will do check it in the demo part. Okay, so this is the agenda for today's session. So okay, let me introduce to myself. Yeah, so this is Veera. I'm working as a senior software developer in tech system. I'm having 3+ years of experience in various domains such as GIS, e-commerce, and supply chain, and decentralized finance. Also, I'm actively writing blogs about full stack development, blockchain, and cloud related services and stuffs also. And then I'm actively participating and conducting events in various communities. Yeah, this is what I am. So okay, let's start get into that. Okay, so why we need a observability driven development? Generally, if we have a application is a monolithic, actually it's bit easy to monitoring, managing, and track it. But when it goes to the distributed system level, it's quite difficult to manage it. So when problem it occurs, we are not sure about where it happens, and then how it happens, how we are going to solve that. If we don't have a proper system, monitoring system, we don't have it, then it will be very very quite difficult, right? Then the failure doesn't repeat exactly. So first time you are facing this issue, you note it down, and then if again, if the same issue or some other issues happening in that time, we don't have any proper tracking system, it's very hard to manage it. So that's also one of the problem that's also needed for our observability driven development. And then debugging is also very very hard if we are having a microservices or distributed kind of system. Okay, even the monitoring no longer can help us. The monitoring means like um, having CPU utilization, and then monitoring the overall applications. Sometimes it will not help us to track the particular API is getting failure, particular system is getting failure in particular some kind of situation, some kind of network traffic, some kind of workload. So that's also will not help us to in sometimes. So these are the reasons we need observability driven development. Okay, so okay, so this is how many of you faced this issue in your production server or any kind of server, right? This is actually very weird, right? It's not a very clear issue. Generally, it will tell your server getting some internal error. We are not able to understand what type of error. If we don't have a proper system, it's very very hard to find out this kind of error in the production server, right? So okay, so if we are facing this kind of issue, what we will do in next? If we don't have a proper setup, proper monitoring and observability kind of system, we don't have it, then what we will do in next? Then we will directly get into the production server, okay, and try to figure out the issue, try to solve that issue, and then we will do some patchwork to solve that issue. That will make some other issues also, right? So this is the some pictorial representation how we will try to solve the issue in the production. Okay, so okay, generally how the logs also will generate look like. This is how it will look like, right? So when you go into your terminal, when you go into your any log file systems, this kind of screens we can see it's very hard to find out which stage it occurs at, right? So we don't have any search. It's not easy to trace it. Okay, this is the root cause of the issue, this is the root effect of the effect of the particular problem. So in these kind of things, very hard to find out the particular issue. Okay, so in okay, how do we feel in that situation? It's very hard, right? Like if you don't have any proper setup, you don't have a proper monitoring system, it's very hard to find out, okay, uh, to solve the issue in the particular uh, the problem when it occurs. Okay, so okay, so what are the components, what are the pillars of observability? Observability have a three categories. We can observe and collect metrics related data. Metrics related data means we can collect the system oriented informations, like how much CPU is utilized in the particular event occurs, particular time in the some particular time where the workload has been increased, how much CPU is utilized, how much memories has been consumed. These kind of things will come under the metrics related category. And then what is trace? Another one is trace. Trace means we are able to track when the particular API call is happen. For example, I'm making some API request, where it goes to in the first step, it will go to our load balancer. Okay, then where it goes to the next step two, it will redirect it to the API gateway, and then third where it will goes, it will redirect to the particular microservice, or it is any particular even the serverless architecture, any particular service, it should redirect it to the particular service. Okay, and then third it will go and check the database. So this kind of things we can consider, we can track under the traces concept. Okay, and then logs. Generally logs we can collect two type of logs we can collect. One is first category of log is application will generate some logs which related to the product details, and another one is system will generate for some systematic logs also. For example, like this user logged in particular time, right? And then this particular services has been running for this much of time. Okay, these kind of logs will come under the system logs. Okay, so these three pillars we have to consider for making observability driven development product. Okay, so yeah, okay, so in market, what are the tools, what are the open source tools available to make our application more observability driven development? Okay, so we have a Elasticsearch, we have a Prometheus also, and then a Jigger also we have that, and then OpenTelemetry, and then Jibkit. These are the open source tool we have in the market. Okay, so today we are going to look into about OpenTelemetry as well as Jigger. These two tools we are going to look into about how it's actually internally is working, how we can implement the observability driven development using this tool in our application. Okay, so okay, so okay, let's check what is OpenTelemetry. OpenTelemetry is the set of tools. It's providing, it's a set of tools. It's providing the APIs and SDK, and then it will help us to integrate our application with some third-party services. That means it will help us to collect some details of our application, and then it will provide the some support, transmit our details, application details, send it to the some third-party services. Third-party services means some visualizing the dashboard, like Grafana dashboard. Okay, and then it will act as a intermediate. Okay, it will collect the details. Actually we have to instrument this tool in our application, Okay, then it will collect the details and then it will send it to the particular third party service, Grafana, Elasticsearch. It will send it to the particular service. Okay, so it will help us to get traces, metrics, and logs. These are the pillars of observability, right? It exactly is doing what we want. Okay, and then OpenTelemetry is mission to enable observability, making more high quality and portable telemetry data, and then vendor agnostic. So these are the features it has. Okay, so next let's check the architecture of OpenTelemetry. So this is the overall and how the OpenTelemetry is working. So okay, in left side we can, in the top we can see microservices, right? This is what actual our services, actual our product applications. In the application we have to install open telemetry related libraries, APIs or SDKs. We have to install that. That will help us to collect the data, collect the like a metrics related data or logs or traces, everything. It will collect it from our services and then it will send it to the uh, open telemetry collectors. Okay, the collector sometimes will work as the exporter also. That means it will collect the data and then it will send it to the some third party services. The third party services we already discussed, like Grafana or Elasticsearch or which one, Um the jigger also. So the more visualizing tools, these we can consider as a third party things. So it will help us, the collector and then exporter will help us to send the data to the particular third party service. Okay, so we can get the data from observability related data from our application, as well as some cloud services also we can get it, like we can collect the data from Kubernetes and some AWS related cloud stuffs also we can collect it, and then some L7 level network layer level proxies also we can get the data and then send it, send, and then we can track everything using this open telemetry tool. Okay, this is how the overall architecture and then how open telemetry is working. So next let's check. We are more towards to focus on uh, tracing part today, other than the logs and then metrics that we already know. The logs means like system related logs and then application related logs. The metrics also like how much CPU is utilized. So but today we are going to move towards like how we can trace the particular API call. This is what we are going to look into today. In application demo level also we are going to do it. So generally how the tracing things is happening in the distributed services. Okay, so for example, if I'm making the API call to the service A, okay, so it will generate unique ID for service A, and then it will that we can consider as a span. Okay, so in right side we can see A, B, C, D, E, right? These each and every component considered as a specific service, or we can call it as a span. So on the particular span of time this particular function is happen. So that's the reason in the telemetry, in the open telemetry, they have a name called span. So for example, uh, I'm making the API call to the load balancer called A. Okay, so it will send the request to, it will say redirect the API call to service B. Okay, so that is the span of B, and then it will redirect to the request to service B, service C. That is called span C. This is how we can track the entire trace. So this is called the entire flow called the trace they are considered. Okay, so this is how the distributed tracing things will work. Yes, a second. Yeah, this is what we discussed, right? The entire flow of the particular API call we can consider as a trace. Each and every trace will have various spans. The spans are like I'm making the API call to the load balancer. Okay, load balancer will redirect it to the particular service, right? So just a second. Okay, this picture will give a clear understanding. Okay, so I'm making the first client making the call. Okay, that is called, that's considered as one of the span. It will redirect it to the load balancer. That's also considered another span, and then it will redirect to the auth module. So that's also considered as the another kind of span. So if the if any problem is occurred, we can we can easily find out which span is getting this issue. Okay, it's a kind of tree kind of architecture that we saw just a second in this diagram. Okay, so it will make kind of some parent children and grandchildren kind of architecture. The data it will generate, through that we can easily find out which service is getting some issue, which service is getting some data. These things we can easily track it. So just a second. Yeah, so this is the same diagram we already discussed. Okay, so just a second. Yeah. Okay. So now I hope you are clear about what OpenTelemetry is doing it. Now we are going to check about, we are going to look into about what is Jigger, and then what it is one of OpenTelemetry collector as well as the export. Okay, so it will help us to visualize our the traces related data. We can easily visualize it. Okay. So it's one of the product of Uber, and then it's inspired by Dapper of it's the initial version of Dapper that developed by Google. That is the inspiration for this Jigger. Then now it's actually donated to the CNCF, the community, and then it helps us to visualize the entire tracing. It will help us to do that, and then it's supporting various languages also. Golang, Java, Node.js, and Python, and even C Sharp also is supporting. So generally, we can even this collector also will directly send the details to Prometheus. Also, we can send it to. So this is actually UI tool that will help us to visualize the entire distributed tracing. Okay, so this is the overall architecture of the Jigger tool. So we need the client as well as the agent that will be installed in our the particular system. Okay, and that will receive the data from OpenTelemetry, collect OpenTelemetry the protocols, the architecture we saw that, right? So it the OpenTelemetry will send the all the data to Jigger. So Jigger will have a Kafka and Fling that will help us to store data in their database. Okay, and then it has UI component also, there we can it actually it providing some query support also. We can find out in between time, in a particular span of time, what are the traces, what are the APIs call happen, what are the issues happen. That we can do it through UI and then Jigger query also. Okay, so this is how the Jigger internal architecture is working. Cool. So next, okay, this is the UI view how the Jigger is working. So for example, I'm making one of the post API call. Okay, so we can see the various spans. This is the overall time to complete the particular process, and then each and every span how long it will take. The span means particular service, particular function is calling. So this is how we can track it. If the particular problem is occur in between, also we can easily find out. So okay, so now let's get into the demo part. I already developed some demo application. I'm just going to explain what are the packages I installed. Okay, so I'm not going to write it from the scratch. I'm just going to install what are the packages we need, and then what are the uh, how we can do it. Then that only we are going to look into it. So this is the project. I will clone it actually. Okay, once installed, so we have to run. Next command is go mod td. So this will help us to install the packages which is required for this application. Okay, so this go mod will have what are the packages we need, and then go some will have what are the various versions. For example, in when I started the application, I installed some version kind of packages, right? Later I upgraded everything, we can track it here. Okay, so this is what it is. So let's check the code first. So I just made a simple to do application. Okay, so the entry point will be in this is the Golang application, so the entry point will be this main function. Okay, so what are the packages we need is I installed Golang gin package. It will help us to create REST APIs. Okay, so and then I installed Mongo drivers. This is for a um, interface for connecting our backend services with MongoDB database. Okay, so BSN, so binary JSON kind of data storage that happening in the MongoDB database inside. So that package we need, and then I'm installing telemetry, the packages. One for tracking the API services. So I install OpenTelemetry in package, and another one is I want to track what happening in the MongoDB database also. So I installed MongoDB OpenTelemetry packages also. Okay, this is the common tool. This is the parent package actually. So I'm creating the MongoDB client here. So this is like we will check it later, this one. Actually this is the Jigger package that created in the separate folder, so that we will discuss it later. So I'm created the connect MongoDB function, and then starter web server function. So connect MongoDB function will have uh, MongoDB connect URL. Okay, and then when I'm starting the database, I'm setting some of the values, like some of the to-do list I'm setting it there. Okay, so this is what the MongoDB connect MongoDB function will do, and then I'm the starter web function. It will create the HTTP server for my application. So generally we can do REST API calls. Okay, so I'm making here line number 56. I'm making to do get API call. Okay, so it will call the database and then collect the to do list. Okay, and then it will send it back to the user as a response. Line number 71. Okay, so this is what it doing it in a connect database as well as starting the web server. Okay, so now let's check uh, the jigger, the collectors. Okay, so let's get into that function. Okay, so I created in a tracing folder. Under folder I created the jigger. Specifically it will jigger related configurations, everything will be written here. So the first one, I'm sending all the open telemetry related data to the particular Jigger port running. So that we already discussed in the part of a Jigger architecture. So we have to install some client, Jigger client, as well as the agent tool in our local system that will receive open telemetry related data, okay, and then it will store it to their database, and then it will display it in the UI. Okay, so that is what we are doing it. So we are sending open telemetry related data everything into this particular port and then URL. Okay, so here I'm configuring what kind of services. So in the dashboard we can see this to do services that we can see it. Okay, so this is the basic configuration for Jira. We have to do it. So in the main.go, in the main function, I'm importing it. I'm actually uh, through open telemetry, I'm passing all the details. Okay, so this is what, how we can instrument our application using open telemetry and as well as the Jigger. Okay, so in code wise we have to do that. We have to install some packages, and then we have tried the configurations for passing the data from our application to the collectors, open telemetry collectors. Okay, so now let's start the application. So so backend server is started. Okay, so now we can see the error is connection refused. That means Jigger setup is not running now. Okay, now let's run the Jigger tool. So I all installed on Docker image. Okay, so let's start the Jigger now. And this is the one of the port we mentioned in the code itself. So that is the entry point for receiving open telemetry the data. Okay, so I hope now it started. Okay, now we can check the details in the UI, the Jigger dashboard. Localhost in the port of 16. Yeah, this is the port we can see Jigger UI. Okay, so this is how the Jigger UI will look like. See, in the services we can see no results found, right? So if, for example, you have a various applications, you have a many distributed services running in your environment. So we can create for each and every services, we can each and every product we can create the own services like we do it in the Jigger tool. And line number 19 we said that, right? This is the to do services, right? So all the services will be displayed here. So now let's restart the application and check, are we able to see the data or not. Okay, server is started. I hope now it's not throwing any, so let's restart it. Okay, are you able to see these to do services now? Right, so I selected that to do service. Let's find the traces. Okay, so the first API calls, when I starting the application, I called in default I'm setting some of the to do list, right, in the database. So that service in main.go in connect mongo, I'm default I'm installing some of the storing some of the data. So that things I can see it here. So now let's make some API calls. I hope that's also we can see it. Okay, so I made an API call. Now let's go back and then let's see. Are you able to see that? This is the API call I made, and then where it goes, and then what are the functions it does. So we can trace it everything. Okay. If any issue is occur, it will really help us to okay what problem is happening, which point of time it occurs. So everything we can trace it here. Okay. So I think hope I make sense for this OpenTelemetry and Jigger tool. Yeah, I think that's
Yeah,
it from my side. If you
yeah,
have
thank you,
any,
Vira.
yeah,
Thank you. That's a great session, actually.
yeah,
We have one question in comment box from Vijay.
yeah.
Should we customize the Jigger.go to accommodate the open telemetry?
So we customize the Jigger. Yes, yes, it's possible.
Okay.
Yeah, we can do it. You
Okay.
mean like what kind of customization you are asking? Like,
Vijay, you can unmute and ask
yeah,
your question.
for file generally the Jigger.go file is the configuration file to pass the data from our open telemetry, our application to the Jigger dashboard. So that's one thing. Furthermore, customization means we can check their official documentation, the Jigger documentation. What are the options they are providing? That we have to check that.
Okay.
I hope I answered.
Yeah, Vijay, do you have any questions about your question?
Yeah, okay, fine.
Okay, fine. Any other questions, guys?
Guys, if you have any other questions, feel free to ask. I will share the link also, this application link also. So you feel free to do your hands on. Okay. Okay, guys. Yeah, that's it for my side. Thanks, Tony.
Yeah.
Thanks.
Thank you. Thanks for the great session, Vira. Thanks a lot. And our next speaker is Aditya.